Alright, so the objective of this lesson is to use the degree and leading coefficient of a polynomial function to determine end behavior. The leading coefficient of the function is the number written in front of the variable with the largest exponent. So in this first one, there's the function is y equals 2x plus 2. So that's 2x to the power of 1 plus 2. X is the variable with the largest exponent. So the leading coefficient of that is 2. Then you have y equals 5x squared plus 2x plus 3. The term with the largest exponent is x squared. So the coefficient of that is 5. And then you have y equals negative 2x cubed plus 2x squared plus 3x plus 4. So in that one, the leading coefficient is negative 2. The last function is 4 times x to the power of 4 plus 2x cubed plus 3x squared plus 4x plus 6. So the largest exponent is 4. So the coefficient is 4. So the leading coefficient is 4. So the degree of a function is determined by the highest exponent in the function. In this first function, y equals 2x plus 2, we have the leading coefficient of 2. The highest exponent is 2x to the power of 1. So 1 is the highest exponent, so it's a degree of 1. And then this function is called a linear function. The next function, the highest exponent is 2, 5x squared. So the highest exponent is 2. So that means the degree is 2. So it's a second degree function, and we can also call it a quadratic function. The next one, the leading term is negative 2x cubed. So the highest exponent is 3. So it's of degree 3, and we can call it a third degree function. Or we could call it a cubic function, because there's a cubed term, and that's the leading term is a cubed term, so it's a cubic function. And then the last one, the leading term is 4x to the fourth, so the highest exponent is 4. So it's a fourth degree function, and we could also call it a quartic function. So now we know what the leading coefficient is, we know what the degree is. So we're going to use these two parameters to determine the end behavior. So what's end behavior? End behavior of a function f describes the behavior of the graph of a function at the ends of the x-axis. So let's take a specific function and see what the end behavior of that is. Alright, so we're going to start with the linear function from our table, y equals 2x plus 2. So the end behavior is what happens to y as x gets increasingly large. So as x reaches positive infinity, what's going to happen on the y-axis? So you can see here that y just keeps going up and up and up. So the end behavior is that as x goes to positive infinity, y also goes to positive infinity. In addition, as x goes to negative infinity, y goes to negative infinity. Alright, and now we're going to work on the next equation, y equals 5x squared plus 2x plus 3. So this is a second degree function. So what is the end behavior? So the way we define it is what happens to the x-axis as x gets infinitely large? What happens to the y? So the way we write it is as x goes to positive infinity, and so as you can see, it's sort of like the linear function. As x goes to positive infinity, y goes to positive infinity. Now, end behavior in the negative. So as x, what happens as x gets increasingly negative? Does y get increasingly negative? No. Y gets, again, increasingly positive. As x gets increasingly positive, y just gets increasingly positive. And then as x gets increasingly negative, y also gets increasingly positive. Okay, so now we're off. We're working on the third degree function, y equals negative 2x cubed plus 2x squared plus 3x plus 4. So for the end behavior of this one, cubic functions will always be like this. As x gets bigger and bigger, y gets smaller and smaller. And then as x gets smaller and smaller, going to negative infinity, y will actually go to positive infinity. So as x gets bigger and bigger, what we notice with this one is that the y gets smaller and smaller, and this makes sense because if you take a number like if x is 5, 5 cubed is 125, and then 125 times negative 2 is going to be negative 250. So what is happening is x gets bigger and bigger, y gets smaller and smaller. And then on the other end of the end behavior, as x is getting increasingly negative, y gets obviously increasingly positive. And then you can, if this is hard for you to visualize, just think of it in terms of numbers. If you take negative 5 and you put that in this leading x term, which tends to, this leading term will, as you get into these higher order functions, will just tend to dominate. And so yeah, negative 5 cubed is going to be negative 125. And then that times negative 2 equals a very large positive number. So that's just plotting one point that proves our point that the end behavior as x gets negative, increasingly negative, is that y gets increasingly positive. Okay, now we're on to the fourth order equation. And for this one, what you notice about the end behavior here is that as x gets increasingly large, y also gets increasingly large. So we write this as x goes to positive infinity, y goes to positive infinity. Now, what happens as x gets increasingly negative? So we write this as x goes to negative infinity, y goes to, what's the answer? What we notice is that on the left side of the graph, y just keeps going up and up and up as x keeps getting more and more negative. So as x goes to negative infinity, y goes to positive infinity. And so an interesting thing about this is what you start to notice is that the end behavior for this is actually the same as for our second order equation. For that one also, when as x got increasingly large, y got increasingly large, and as x got increasingly negative, y got increasingly positive. So it's the same end behavior as the second ordered equation. And so what we're going to learn is that, so this is the fourth order equation, second order equation. So and that's going to be the same end behavior for the sixth order equation and the eighth order equation, and for any equation with an even degree, it's going to have this type of end behavior. All right, so let's put it all together. What we just learned was that if you have a graph that's fourth degree or any even degree, so if it looks like y equals x to the fourth plus some other stuff, the end behavior as you go as x gets bigger and bigger is always going to be that y is getting bigger and bigger, and as x is getting increasingly negative, y will get increasingly positive. So this is if the leading coefficient is positive. Now, if it's negative, what happens? It's just going to be the mirror image of that. So if we got something like y equals negative x to the fourth, or y equals negative x squared, or y equals negative x to the sixth. So if you have negative leading coefficient and an even exponent, it's always going to be as x gets increasingly positive, y will get increasingly negative. And as x gets increasingly negative, y will get, again, increasingly negative. Okay, now let's go back to, there's that one we did for the third order equation. That one looked like this. So as x got increasingly positive, y got increasingly negative. And as x got increasingly negative, y got increasingly positive. So this is going to be the same for any odd ordered function, so with a negative leading coefficient. So y equals negative x to the 5th, y equals negative x to the 7th. It's all going to have the same end behavior. So guess what happens if the leading coefficient is positive? Okay, if leading coefficient is positive x to the 3rd, this is just going to flip. So it's going to go something like this. So in this case, as x gets increasingly, goes to infinity, y will also go to infinity. And as x gets increasingly negative, y will also get increasingly negative. And this will be the same, for y equals x to the 5th, y equals x to the 7th. It's always going to be the same. Okay, and to sum it all up here, this handy-dandy chart shows you what the end behavior will be depending on if the leading coefficient is positive or negative, and if the degree, meaning the leading exponent, is odd or even. So this basically sums up everything in this video. Thanks for watching.